Moving on to level 1.2, we're going to be looking at and examining some information about the graph of a function. So the most important thing that's going to cover this level is the vertical line test. We should see this before, but if you haven't, here's a reminder of what the vertical line test is. It says, for a graph to be a function, it must pass the vertical line test. And the vertical line test says that if the graph of a function hits a vertical line in more than one spot, then it's not a function. Vertical line only touch graph exactly once. So that's the vertical line test. So just as a quick start, we'll look at these first couple. So it says, which of these graphs in the figure below are graphs of a function? So we look at A, and no matter where we draw a vertical line, it only hits our graph in exactly one spot. So this is a function. We look at B, same thing. No matter where we draw our vertical line, it's always going to touch our graph in exactly one spot, which means it's a function. For C, we have x equals y squared, which is a little different. We can see that if we start drawing in vertical lines, it hits in more than one spot. So this is not a function. And same thing for D. We have a circle, which we should know the equation for by now. A little callback to the last level, level 1. And we can see that a circle is not a function because it hits, a vertical line hits the graph in more than one spot. So this is not a function. And just as a reminder from level 2.1, if we're given information as a point, so x, y is a point on the function f, then just to be more specific, we say that y is the value of f at x, or y equals f of x. And so if we plug in a number, that's just plugging in two for x, and we usually get a number out for y. So we'll use these interchangeably, as f of 2 means the value of y, or the function value at 2. So let's try example 2, and then we'll be close to being done with this level. So given the graph, what is the value of f of 0? So f of 0 is, what's the y value at 0? So we can write f of 0 equals 4. Then we can look at f of 3 pi over 2, or what's the y value at 3 pi over 2? Well, we find that on our graph, which is right here. That's equal to 0. And then we can also look for f of 3 pi, which is, what's the y value at 3 pi? So I go to 3 pi here, and it's negative 4. So now, what is the domain of f? The domain, again, is all of the possible x values that I can use. So since this picture is limited, my domain would be all the values x from 0 to 4 pi. 4 pi being the furthest right I can be. So I'm going to include both of those. So we go to our set notation. We use brackets, so we go 0 to 4 pi, and both of those are included. Remember, brackets means we're including points. If we use parentheses, that means not included, or that's our less than or greater than. So then we look at our range. Let's use a slightly different color for that. How about green? So for our range, we look at what are our y values? What's our up and down? So in this graph, the highest we can be is 4, and the lowest we can be is negative 4 for our y values, or our outputs. So we write our range as negative 4 to 4. These are all of the possible outputs that we can be. Next up, list the intercepts. So this is a callback. Intercepts means where does it cross the x or y axis. So our x-intercepts, we have 1, 2, 3, 4 intercepts. We have pi over 2, we have 3 pi over 2, and remember, whenever we're asked for intercepts, we write as ordered pairs. The next one is 5 pi over 2, comma 0, and the last one is 7 pi over 2, comma 0. Those are all our x-intercepts, and our y-intercepts, we have 1 at 0, comma 4. And the last one, for what value of x does f of x equal negative 4? So that's saying, if I know my y value is negative 4, what's my x value going to be? So I can look at my graph here, and there's 2 spots where I'm negative 4. So x could either be pi, or x could be 3 pi, because these are the 2 spots in which x yields negative 4 as a result. One more on this. So for what values of x is f of x greater than 0? So this is looking for where are all my positive numbers, or where am I getting everything above? And I'm going to write this in 2 forms. So we have from 0 to pi over 2, but we don't include pi over 2. So we have included 0 to pi over 2. Then we use this sign to say union. So we union. Well, where's the next positive set? Well, we want to be greater than 0, so it's going to be 3 pi over 2, 2, 5 pi over 2. Union, I know we have one more, which is 7 pi over 2, comma, 4 pi. And we include that last piece because it's included in our domain. So that's what we're going to be looking for the values for here. If we flip it over, we'll be in the last problem. Moving on to example 3, we have a slightly new function. It's a rational expression. We have f of x equals x plus 1 over x plus 2. So it says, first one, is the point 1 comma 1/2 on the graph of f? Well, if we recall back to level 1, to tell if something is on the graph, we plug it in to see if it's true. So we're going to plug in 1 for x and 1/2 in for f of x, or y. So we have 1/2 equals 1 plus 1 over 1 plus 2. So that's 1/2 equals 2 over 3. And I'm going to write a question mark over the equal sign. That's obviously not true, so therefore, those 3 dots again, 1 comma 1/2 is not a point on our graph. Let's try the next one. If x equals 2, what is f of x? What point is on the graph of f? So for x equals 2, f of x, so f of 2 would be 2 plus 1 over 2 plus 2, which is 3 over 4. So the point that would be included would be 2 comma 3/4. So for C, if f of x equals 2, what is x? What is the point on the graph? So we're going to again say, well, now f of x equals 2, that's saying like y equals 2. So we are going to write 2 equals x plus 1 over x plus 2. And now we're going to solve, so we can cross multiply. We get 2x plus 4, which is 2 times x plus 2 if you want, equals x plus 1. Now I'm going to subtract x and subtract 4. I get x equals negative 3. So that's the x value that yields 2 out. And so my ordered pair that I'm going to write is negative 3, comma 2. And D to finish off this level. What are the x-intercepts of the graph of f? What are the points on the graph? So, x-intercepts. Remember from last time, plug in 0 for y. And now we can say or f of x. So we have 0 equals x plus 1 over x plus 2. Again, we can cross multiply, which just cancels out this denominator, which leaves us with x plus 1 equals 0. Now we can easily solve. We have x equals negative 1 is our only x-intercept. And the way we write our x-intercept, because it's a point, we write negative 1, 0. So hopefully this gives you a little help moving into the 2.2 problems.